Surds. A surd is a square root of a number that is not a perfect square, a cube root of a number that is not a perfect cube, and so on. So the fourth root of a number that's not a perfect fourth power, and so on. Surds are irrational numbers. Now, let's just explain this further. If you think about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Root 1 is not a surd because root 1 is 1. Root 2 is a surd because 2 is not a square. Root 3 is a surd. Root 4 isn't because the square root of 4 is 2. And so on. So here we're giving an example of root 4 being 2. That's a rational number, and therefore it's not a surd. But root 7 isn't an integer. So the square root of 7 here. 7 is not a perfect square. So it's an irrational number. It starts as shown here. But like all irrational numbers, it's got an infinite decimal expansion with no recurrence pattern. One of the things we need to be able to do is simplify surds. There are some standard rules when dealing with surds. This helps us combine two or more surds and to break up surds. So the square root of a times b is equal to the square root of a times the square root of b. That's actually just an index law. So all we're saying there is ab to the half is a to the half, b to the half. And this is an index law that we know and have used in the past. And so this is also true that the square root of a over b is the square root of a over the square root of b. Again, that's just an index law. When simplifying or breaking surds apart, it is best to look for the highest factor that is a square number. So I've got a list of square numbers here, and it's usually best to look for the highest square number factor that we can find.